Today we are taking u-substitution a step farther. We're going to be doing u-substitution with definite integrals. U-substitution with definite integrals. What we are doing today is approximately 80% exactly like what we've done for the last couple of days. The similarities are uncanny, but there are a couple of changes. What does a definite integral have that an indefinite integral does not? The limits of integration, the a and the b, and that's what we've got to deal with today as we do these problems. Okay? So, I have 3 examples for you. Here is the first one. The integral from 0 to pi over 3 of tangent of x secant squared of x dx. The integral from 0 to pi over 3 of tangent of x times secant squared of x dx. Anytime you see an integral that has more than one trig function in it, it will be a u-substitution problem. Always. 100% of the time, guaranteed. Every time. Okay. But Ms. Bell, did you have to pick tangent and secant? Why not sine and cosine? So much easier. Well, sorry. We have to deal with these as well. Okay? So, we are going to start exactly like we started before, figuring out what is u and what is du. Now, this one is kind of tricky because some people think, well, this is the one with the power, and it's the one that's inside of the other one, so that's probably u. But you've also got to look at it this way. Anytime there's 2 trig functions in a problem, usually one is u and the other is du. So which one of these is the derivative of the other one? Secant squared is the derivative of tangent. Okay? That whole thing is the derivative. So it makes sense then to make u the tangent of x and du the secant squared of x dx. Because secant squared is the derivative of tangent, it is the du, even though it's squared. Okay? Now we change colors, because it's time to turn this integral into u. So we draw the integral. Do not write down the a and the b, and I'll tell you why in a minute. So, this tangent of x, what do I write in my new integral? Just u. And the rest of this, secant squared x dx, is du. Wow, we just took an ugly trig integral and we turned it into a u du. Very nice. Okay? Now, this is in terms of x. This is in terms of x. These limits are also in terms of x. Since we have turned the rest of the integral into u's, we must also turn the limits into u's. So this is where we now go down a different road. I need you to draw a 3-line long t-chart. X goes in the first column, u goes in the second. And we're going to change the limits of integration from x values to u values. So what I want you to do is I want you to copy these 2 values exactly as you see them in the x column. X, pi over 3 and 0. The one that's on top, put on top in the chart. Because sometimes when you change them, the bigger one turns out on the bottom. They switch places. You're not supposed to mess with them if they do, but it might happen. Because usually you know that the smaller one is on the bottom. So it's important that you keep these in the order that they're written here, and that when you get your u's, you transfer them exactly as you see them back over here. Are you with me? Okay. Now, I need to figure out how is x related to u. What on the paper tells me how x is related to u? The u equals tangent of x. So I have to, in order to find out what u is, I have to plug both of those into tangents. So I'm going to be finding the tangent of pi over 3 and the tangent of 0. This is like my work column. That's what I'm mathematically doing. Okay? Now, for those of you who are a little rusty on your trig, which I think is probably most of you, I'm going to come over here. Actually, I'm going to go ahead and draw it right here. And I'm going to draw quadrant 1. Where's pi over 3?
The second one from pi over 2.
Okay, it's like close to the y-axis, right? This is pi over 3. And I need to know the coordinates right there. What's the x coordinate? 1/2. And then square root of 3 over 2. Hopefully you can get that. Okay? In terms of those coordinates, what is tangent? It's the y over the x. So I'm going to come down here and I'm going to put square root of 3 over 2 over 1/2. Yes. Then you take the bottom one and you flip it up. The 2's cross out, and your answer is the square root of 3. Now, the reason I'm writing in blue is just to make it stand out. It's a u value, so I'm going to write it up here in red. Okay? Did everybody follow what I just did? Okay. Now, tangent of 0. Where's 0? Right there. What are the coordinates? 1, 0. Now, put the y over the x again. What do you get? 0 or undefined? 0. You get 0. So that's a 0. So now, since I know what my u coordinates are, I'm going to bring them over here and put them on the radical, square root of 3 and 0, just like so. Okay? Now, it is time to integrate. Change number 1 from what we did before is the chart. Change number 2 is the fact that we are not going back to x's. We're going to finish this problem in terms of u. Chris, what were you going to ask?
What if we ever go like pi over 2 and it's under, like with the tangent? And
You never will. You will always get a value that you can solve. Okay? In this class. In a later calculus class, maybe you might see that, but not in here. Okay? Good question. You will always get a number here. You will never get an undefined. Okay. So now, how do you integrate a u? I'll give you an easy one. This happened first period too. They're looking at me like, I don't know. But it's easy. Okay, what's its power? 1. So, parentheses, u. What does the power go up to? 2. What goes in the parentheses? 1/2. And we bring the two limits of integration, the 0 and the square root of 3, over. Remember, we don't do plus c on definites. We keep going in the same color. So this is 1/2 of the square root of 3 squared minus 1/2 of 0 squared. And then we work that out. What is the square root of 3 squared? 3. So that's going to be 3/2 minus 0. So the answer is 3/2. It is much easier to leave it all in terms of u and plug in the u values, because it's a lot easier just to plug in the square root of 3 to having to plug into a tangent. Okay? So, recap. What did we do different? We created this chart right here, had to change the limits of integration, and then we stayed in u's all the way through. That's all that is. Okay? So let's practice another one. Here we go. Example. Move it up. The integral from 0 to 1 of x over x squared minus 4 dx. Yes?
about the problem of what if we had something like sine of cosine, and would there be a problem where we would need to use like a trig rule to substitute in a tangent?
Not until BC calculus. No. Okay. Yes. No worrying about trig identities and stuff in this class. That's BC stuff. Yes. You just need to know your basic trig rules, the y over the x, you know, how secant, what's the reciprocal of secant? That's something you would need to know, for example. Secant's the reciprocal of what? 1 over cosine. I was talking to I was teaching a pre-AP pre-cal class the other day. You know that secant, okay, I said cosecant is the reciprocal of what? And they said sine, because you can't have coco. You can't have cosecant and cosine together. I thought that was interesting. You can't have coco in pre-cal class. So you can't have a co with a co. Kind of an interesting way to remember that. You get what I'm saying? Secant goes with cosine. You can't put secant, you can't put cosecant with cosine because you can't have coco. Coco is not allowed. I was like, that's kind of interesting. Okay. Now, we have actually done this problem before. We did it in the notes before. What did I tell you when there's a fraction that u is usually? The numerator or the denominator? Denominator. And because not one of them is inside of anything else, you have to go with that rule. This is x squared minus 4. What is du? 2x dx. Okay, so switching colors. Draw your integral sign. Do not write the 0 and 1 down because they are changing. U is in the denominator, so I'm going to draw a fraction bar, put a U. Do I have everything I need for du? No. What do I need? So throw a 2 in there. What goes outside? 1/2. 1/2 goes there, 1/2 goes there. So all of this is du. Pull it out to the side, put a 1 on top. Now we need to change the limits. X, u. Bring over the 1 and the 0. And where do we plug these in again to find the u's? The u equals. So this is coming down here, so this is going to be 1 squared minus 4, 0 squared minus 4. If you need to write this down, great. If you don't need to write it down, just mentally do it. What's the first u going to be? -3. What's the second one? -4. So we put -3 on top, -4 on the bottom. Yes?
If you got them and they switched, like the one that was smaller became bigger, would you still put them in the same order on the integral?
Brittany just asked a very good question. Let me say it again so that the video recording hears it. If these numbers happen to switch to where the bigger one was on the bottom, would you switch them over here, or do you have to keep them in the same order? And you have to keep them in the same order. Okay? So, if you wanted to switch them back because you didn't like the fact that the bigger one was on the bottom, then yes, you would have to put a negative sign. Otherwise, just leave it alone. Usually what happens is if they switch, it all works out at the very end to make it come out to the correct sign. Okay? So, now we go ahead and integrate. What is this? That's ln. ln, absolute value of u without a plus c from -4 to -3. So now you need to remember your log rules a little bit because we're going to be plugging in. So we're going to have 1/2 the natural log of the absolute value of which one first? -3 minus 1/2 the natural log of the absolute value of -4. Now, if we didn't have absolute values, we'd have undefined answers because you can't take the natural log of -3. You can't take natural logs of negative numbers at all. So this is 1/2 natural log of 3. Now you can just take the bars off because you're changing it to the positive. Minus 1/2 natural log of 4. I want to write it as a single natural log. So I'm going to factor out the 1/2. I'm going to write the natural log. What happens to the 3 and the 4? They go over each other. It becomes division. Remember that when two natural logs are subtracted, it becomes division. Let me add an extra step for some of you need to see it. ln of 3 minus ln of 4. When these two are subtracted, it becomes division. If these two were added, what would it become? Multiplication. It would turn into 12. Okay? So that is the answer right there. 1/2 the natural log of 3/4. Single term. Okay, any questions? I do have time to finish the last one. It's going to be quick, and it's easy. So we like that. Is everybody done writing this down? Okay, last example. Okay, last one. Integral, -1 to 1, 5r over plus r squared dr. Doctor. This is the doctor integral. dr. Does the fact that it's an r bother you? It shouldn't. It shouldn't. I think in regular math we tend to stick with x's and y's more, but the STAR test is making us switch. But those who have taken the regular geometry algebra 2 pre-cal, I think it bothers them more than the pre-APs, because in pre-AP we start right off the bat and we start throwing thetas and r's and q's and all sorts of stuff at you. I don't know. Okay. U equals du equals. Okay. How many of you think you know what u is? Pretty well sure you got it. You know what u is. Just a couple hands? Really? 4 plus r squared. Very good. It's the inside function. So what is du? 2r dr. Okay, switching colors. Oops. That's if I don't drop my pen. Integral. Okay. So we have fraction bar. What's on the bottom? U squared, because remember it's in the parentheses squared. Okay. Now, I have a 5r. I need a 2r. What do I do?
Take it out.
Take it out. Throw it outside. What do I put in its place? Put the 2, put the 1/2 outside. So this becomes 5/2. This is du. That's a 1. Okay. Now we got to change our limits. X, u. 1, -1. Okay. Now I want you to try to finish it. Remember where you plug in the x values to find u? Something unusual is going to happen. Yeah. We got it. Why are we getting 0? It's 5 and 5. So these came out the same, so I can stop right there and say it's 0. Okay? You now have the knowledge to complete worksheet 2 on substitution.